prove that root 2 is irrational number, and we know that irrational number is a number that can be written as non-terminating decimals, and again it is a number with non-recurring decimals. So by method of contradiction, we can assume that root 2 is irrational. Just assuming that root 2 is irrational number, and we know that let's assume it's a rational number. We know that a rational number is a number which can be written as a fraction, that is p over q, where q is not equal to 0. So let's assume that our root 2 is irrational number. So it will be p over q, and let's remove the root here by squaring both sides. How you get it is 2 will be equivalent to p squared over q squared. So multiply through by q squared, and you will get that our 2q squared will be equivalent to p squared, because this and this will cancel off. You are able to know that your p squared is 2q squared, which means that p squared is even number, and we know that the square root of even number is also even number, which means your p, you can write it as 2 multiplied by something. This is even number, so it will be 2. This is the value of p. When it is squared, will be equal to 2q squared. So squaring this side, will get it is 4d squared will be equivalent to 2q squared. Divide by 2 both sides, you divide by 2, and you get that your q squared is 2.d squared, which means it is also even number. But the first assumption, GCD of rational number is always 1, but here we are getting that p was even number and the q also was even number, which means it's like you were writing like 2 over 4, this being p, this being q. Then you cannot leave it at this point, you have to simplify further to get it like this. That's why we are saying that both the p and q were even numbers. So you conclude by saying it is by contradiction. Root 2 is irrational number, because both p and q are even numbers, and this is by contradiction. By contradiction, you get that both were even numbers, and you cannot leave fraction when both have another multiple. It means both P and Q had another multiple, which is 2. They had a multiple of 2, which means you could have simplified further. But if it were a rational number, it could have a multiple of 1, let's say like 3 or 5. There is nothing you can cancel further, but this one you can still cancel. Kindly subscribe and share.